All right, it is 7 p.m.
We're live.
Let's get the show on the road. Hello, everyone. This is the Warren Astronomical Society. We've been around since 1961. I'm Bob Tremblay, your president, at home right now because I don't want to infect everybody out there at Macomb because my granddaughter gave me something, and I'll have the really cool voice tomorrow. So, Dale, this is up to you. Do we have any first-time attendees there at Macomb?
Any first-time attendees? Oh, our speaker.
Where'd he hear about us? Probably you.
Right. I went to a Seven Ponds meeting where he gave a similar presentation and invited him to give this talk.
All right. Well, if anybody in the membership needs to renew their membership, you can pay via PayPal or I don't think is David on site? No, David is not on site. So you're doing it via PayPal tonight.
PayPal or yep.
All righty. So if anyone wants a lanyard with a WASP badge with your name on it, let publications know. That's publications@warrenastro.org. So as a tradition, we like to go back and forth through the ranks of the meeting and have attendees give their name and so let's start with that. Dale, that's up to you there, I guess.
Okay, let's start at the front. Real loud.
Tina Wong for System Party Crasher.
A party crasher, okay.
Eduardo Saluso. Bob Berta. Angelo Donato. Martha Dowd.
Maura.
And Ron Kyle.
And Dale Parton, first vice president.
All righty.
How about the people online?
Yeah, well, I'm thinking everybody count off, start count. Everybody says one at the same time, but well, let's do Dale. Let's start. Dale, Teamy.
Yep.
Yeah, that's it. And
Here.
Bob Tremblay, and we've got David Baranski.
David Baranski, treasurer.
And Charles.
Charles Strackbine, secretary.
And Doug. You got to unmute. There you go.
Yeah. Doug Bach.
Hopefully you're gonna have some photos for us. Smurf.
Oh,
Okay,
wait
wait a minute.
Mhm.
We got two more people just walked in.
Oh, we do.
Is this the first time here for either of you?
Yes, for me it is.
Okay,
Oh,
what is
really?
your name? What is it?
Kim.
Woohoo.
Kim. Okay. And would you like to introduce yourself? Okay. We keep having people walk in. And you want to give your name?
Well, that's awesome.
Galileo just walked in.
Awesome. I have questions for him.
Okay, back to you, Bob.
All right, continuing on. Let's see. We've got Brian.
Yeah, enthusiastic new member.
Awesome. Mike.
Yep, Andrista.
And Catherine. Guess not. And Gerald Dunifer. Say hi, Gerald.
And you have Kelly.
Yeah, it's not. And I don't see that. Oh. Well, hi, Kelly. All right, so
Hello from Gary.
doing a roll call online is confusing. But anyway, so going through some announcements. Brother Guy Consolmagno will be at Cranbrook Institute of Science Sunday, March 17th, and I've talked with him. I announced this at the Cranbrook meeting. I talked to Brother Guy the next day, and I said, "Yeah, this is the first I heard about it." He says, "Oh, I didn't tell you?" I'm like, "No." He says, "Oh, well, can you show up?" I'm like, "Oh, okay, sure." But I guess I'm going. So
Is he giving a presentation?
Yes, he's giving two of them. I guess he's giving a public and a private one. But I guess you have to sign up. Cranbrook posted something on Facebook, and it should be on their website. But yeah, it's definitely I'll share a link if I find it after I'm done talking here. So do we have any calendars left? Although Dale is not there to hand. We had like a couple of them left. We might have a couple of our WAS astrophoto calendars. There may be available.
I think I have some.
They're $15, but you can get them at the Cranbrook meeting, assuming that David is there with them. So WAS wearables are available from Mark Kezier. You can check out what's available in our awesome newsletter. And if Mark is not there at Macomb. Oh, there's the calendar. Yes, we still have some. They're $15. I'm sure he'd like to get rid of those. So
2024.
Nice. WASP wearables are available again. You can check what's available in our newsletter. If you haven't figured out what you're doing for the April 8th solar eclipse, you probably need to figure it out. And Cranbrook, if you're not going to see the eclipse, I don't know why you'd be doing that. Cranbrook would like help. And the Stargate, we have a message board at Stargate. We have the key to it now. So if anybody has any ideas for things you'd like to put in that message board for the public to see when they go to the observatory, let the board know. And there's David showing our awesome calendar. I love it. So, quick officer reports. I finished and released a podcast for the Vatican Observatory. I put a link in the chat there. This was when we talked with Brother Bob Mackey, who has Brother Guy's old job as curator of meteorites at the Vatican Observatory. Brother Bob is on the OSIRIS-REx asteroid sample return analysis team, and he talks about getting in the clean suit and doing all that stuff. And then he's also on the Lucy mission team, so he talks about that briefly. But Lucy ain't getting there for a while. So, Dale, do you have anything? Dale Parton.
As always, I'm after more speakers. Don't be shy. If you have something in mind, please.
Don't be shy.
Yeah. And the other thing I'd like to say is I was contacted by Mike Narlack at Cranbrook saying they really need some of our people to show up at Cranbrook on April the 8th to help people see the partial eclipse that'll be visible there. And they give us a free place to meet every month. So I told them I would take personal responsibility for seeing if I could find people to be at Cranbrook on that date. I'm thinking of skipping the total eclipse in Ohio so I can be there. So because if we don't keep Cranbrook happy, we lose a place to meet. I saw the one in 2017.
When at Cranbrook, I asked the same thing. I asked if anybody in the audience was going to be staying, and nobody raised their hand. Everybody's vamoosing. So I hate to ask you to do that, Dale. I'm going to give you a big thanks. Yikes.
Well, Riyadh's probably going to the eclipse, like everybody else.
Well, this is Doug. I don't plan on heading to Texas for the eclipse. If it happens to be clear in the Ohio Valley, that's the only option I'm going to take. I'm not willing to drive 2 days for a 3-minute, 4-minute eclipse because I've seen several of them already. But let's say it's cloudy in Ohio Valley, but maybe it's going to be clear in Michigan and I end up staying in town, if you will, then I might be able to come over to Cranbrook. I do plan on going to see it, but I'm not going to go more than 1 day away.
Okay. Yeah, I was only going to go to Ohio myself, not to Texas. But at this point, I'm going to be in Michigan. Back to you, Bob.
All righty. So, Riyadh, any news from the observatory?
No, nothing really new. We met, as you know, last open house. It was a little cloudy. We had a few members from the general public that showed up. And our next meeting is on the 24th. So hopefully people will show up. Hopefully it's going to be clear as well. This is a good time to observe the winter sky, especially the Orion Nebula, and maybe look at Sirius. Look for the pup, for the double star, and we'll have a lot of other objects to look at. So let's hope it's going to be clear, and we'll have a good observing session.
Thanks,
Thank you.
Riyadh. We have a lot of first timers. So what Riyadh's talking about, we have an observatory at Walcott Mill Metro Park. It's in Camp Rotary on 29 Mile Road between North Avenue and Romeo Plank. Every fourth Saturday of the month, we have an open house, and we open up the observatory to the public. Or rain, but it's generally rain or shine. We've had people there even when it's raining, and there's also a couple buildings where scouts oftentimes rent the place out and do overnighters, and they oftentimes see our observatory and come over and say, "Hey, what's up?" And then they want to schedule time later on. So anyway, every fourth Saturday of the month we have an observatory, and come on out. We'd love to have you. So, Treasurer David, what we got going on with the banking?
Okay, so in the bank account tonight we have $25,880.01. That's what's in the bank account. It's all no withdrawals so far. It's all been credits and deposits, and so we got lots of money in there.
You know how many membership signups we had this year so far?
Oh God, I think I did about 50 or so.
Yikes.
Yeah, I did a lot of. I just like all I did all day was deposit. And then so I would just, me personally as treasurer, I would say let's dedicate that to the observatory, and don't spare the pennies.
Gets my vote. Alrighty, Secretary Charlie. Gotta unmute Charlie. Sorry. There we go.
All right. Hey, good evening, everyone. This week we created an updated and refreshed letterhead, and also used that to create a letter for Dave to use with the bank. And it's called an authorization to borrow. Not that all that matters, but that's what it is. And it took a minute to pull that together. And I wanted to come out and say that I think we've been looking for things to put in that observatory box out there. And we've got these Boy Scouts and maybe some other school to reach out to. And maybe they can do some art projects or something, describe phases of the moon and some of that type stuff, or leave it up to them. But I think, it'd be great just to study the moon, and they could talk about that and maybe put up a moon chart, something like that.
Wow, astronomical art from kids in there. That's a great idea. I like it. Alrighty, thanks, Charlie. Jeff McLeod, our outreach guy, is not here tonight. So again, we have a lot of first timers. We've got a whole bunch of people that have telescopes and do presentations. So they will come out to your site, set them up, and give presentations about astronomy and space science for free. So if you would like to have a talk about practically anything, just contact outreach at warrenastro.org, and we'll get you somebody to do something for you. Publications. Vichalia is also not here, but Dale Team, you can take over for her. And
I can.
You can. And the newsletter is up. Let's put a link to the newsletter.
Oh, you're stealing my thunder now.
I'm okay. I'm sorry.
The newsletter's up.
There you go.
And I just checked the roster. We're up to 75 members now.
Cool. Okay, I just put a link to our latest newsletter in the chat.
Okay.
So if you need to contact the board for any reason, you can contact us at board@warrenastro.org. So getting into astronomy in the news, I'm going to start doing this all the time. Exoplanets. I used to do this in a post I was doing for the Vatican Observatory, but the number changes every single week. But where there's 5573 confirmed exoplanets and 7,052 candidates. And that's just crazy. If you haven't seen the Juno photographs of Io, let me copy that link and put that. Juno flew by Io and took some of the best pictures since the Galileo, and they're just amazing. They got plumes from volcanoes and just high res pictures. It's just gorgeous. And if you, NASA, the Ingenuity helicopter, busted its rotors and is no longer flying. I saw something from Scott Manley saying they might do a little bit of testing with the rotors, but it ain't flying again. And the rover is going to be moving out of communications distance soon. So for something that lasted what, like 3 years on a 1 month mission, I thought that's pretty darn good. So David Levy is not here, so we don't have that. So solar images. I've got. Can I copy that? Just put that. Yes, I can. Put that right into chat. This was from spaceweather.com. Maybe let me do that. Copy image, not crop image. Copy. There are a lot of sunspots. You're not gonna let me do that. Anyway, spaceweather.com has a lot a solar image, and there's 1, 2, 3, 4, 5, 6, 7 sunspot groups. A giant one rotating out of you. And spaceweather.com had something this morning saying that there was a halo CME, which is a giant CME on the back of the sun, and it's not going to hit us, but it's going to hit Mercury, and it's going to hit Mars on the 17th. And CMEs that hit Mercury can cause ground level aurora, which I didn't know, so that's pretty cool. Any other special interest group? Riyadh, you're going to be taking a look at double stars. Anything in particular you're going to be looking at, assuming it's clear?
Yeah, assuming it's clear for sure. Sirius, we're going to look at that, and also there are a few double stars in Orion constellation, so we'll look at that as well. So there are a few of them.
Awesome. If you have any ideas for a special interest group that you would like to form, there's been talk before of creating a radio group and a computer and technology group, and I'd like to see something done with an education group and light pollution and podcasting, whatever. If you've got any ideas, go ahead and start it and let us know about it. So, do we have any questions, astronomy questions, or questions for astronomers from the audience? Anybody there at Macomb have any questions? We have a bunch of newbies.
The meteor over the Midwest on Monday was large, seeded 5 states.
Dale vanished.
I'm
Dale,
back.
do we have any questions from the astronomy questions from the audience, especially since
Well,
we have
Laura Wade seems to be asking something about a meteor that appeared over the United States.
Midwest, 5 states it was seen in.
She says it was seen in the Midwest over 5 states. I didn't even hear about it.
NASA's got a picture.
Well, I'm checking the American Meteor Society because that would be the place to do it. What date and time?
It was
Monday.
Monday, which was what?
Meteor over.
Why are you not popping up?
Over St. Louis.
All right. Well, I will look at this. Oh, here's the reports. I don't have time to look at these reports. I put in chat. There's the reports from the American Meteor Society. It'd probably be there. I'll look at it during the break. So I'm checking the American Meteor Society. There is you can report fireballs if you see one, and you can see events, and it will let you know. The event listings are pretty cool. It'll actually show how many reports they had, if there was sound, if there's video. So that's pretty cool. So if you ever want to know about a fireball or a bolide that appeared over the U.S., American Meteor Society. All right, so observing reports and astro photos. Do we have any observing reports from any of our audience? What do you got?
I got one clear night this last month. I'll share my results. Let's see here. There we go. Got that?
No, not this year. Oh, you gotta allow sharing.
It says I'm sharing.
Wow.
I see sharing.
I see it.
What am I not seeing?
So that was
there it is.
That was a little over 9 hours of data on February 5th. Basically the night of the 4th, 5th. This is day 81.
Look at all those star forming regions.
Spectacular.
That is spectacular.
So that's the only clear night I've had since November that I actually got out and did anything. So it was just last week. And that's 111 5-minute frames stacked in Deep Sky Stacker and then processed in Pix Insight. And it's probably the best 81 I've gotten. I haven't touched 81 in about 5 years, so I thought I'd go back with my newer camera with my 10-inch RC and give it a shot.
Well, I'm glad you did. That's beautiful.
Wow. Better than it looks in my telescope, that's for sure.
It looks better than it looks in the 18-inch too. So that's the only image I've taken in the last 3 months.
Oh my goodness. Nice.
Had it rotated significantly since the last time you saw it?
I didn't put my micrometer on it to determine that. I didn't check the position angle, Dale.
You're slipping.
10 supernovae appeared and disappeared in that amount of time.
I'm getting old, so I forget to do things, Dale.
I don't know if you guys can see
telescope out
anything
last
on the
night.
screen.
Up a little. Up a little.
Laura Wade is handing me her
go.
cell phone. I'm trying to show it to you.
That looks like a bolide. There you go.
There you go.
There it is.
That's a bolide. Where was that?
I'm trying.
There you go.
It's quite a delay.
That's a classic bolide. Very cool.
There's a lot of videos on it.
She says there's a lot of videos on it.
I will search for those during the break. So I don't necessarily have an observing report, but yesterday I published the newsletter for the Vatican Observatory Foundation, and it drives me nuts. I get a whole lot of automatic replies. I'm out of office and that kind of stuff. And but one of them, I just glancing through, and she said, this one woman says, "I'm out of office. I'm busy working on the NASA I a 4-letter acronym lunar lander, and I'll be responding sporadically." And I'm like, oh my goodness. I'm like, I responded to her immediately. I said, is there anyone, can you or anyone from your office talk to the Warren Astronomical Society about this? Because this would be something they'd be interested in. And she replied back that she was actually a student in the Vatican Observatory Summer School in like 94. I wrote Brother Guy that, and he said, oh yeah, she's a friend of mine. I'm like, oh my goodness. But so I'm going to try to get this woman talking to talk to us, or someone from her office to talk to us about, active lunar lander. So that'd be cool. Any other observing reports and or astro photos? If not, we can.
I have something.
What do you got?
So I think it was last weekend, Saturday. It was clear, and I was looking at Jupiter, and usually when I look at Jupiter and the Galilean moons, they're usually sort of in somewhat of a horizontal-ish type line. But when I looked last week Saturday, it was in a vertical line, and I'd never seen that before. It was sort of in the somewhat
time
of a part of the western sky.
Time of day you're looking at it?
About somewhere between 8 and 9 o'clock in the evening.
Well, what I would do is I'd bring up Stellarium and
Yeah.
to see because it does rotate across the sky, and so that the plane those are going to change. But yeah,
But I thought that was really curious. All other times I had seen it, the moons were in a horizontal plane, but this time it was in a vertical.
Well, it also depends on your alignment of your mirrors. So if you have a diagonal that's twisted, that may do that too.
Okay.
And depending on the telescope you're using, if you just rotate the eyepiece, you'll see the line of the moons rotate.
No kidding.
Try it. It's pretty easy to try.
Really?
Had not even thought about that.
Rotate the diagonal, not the eyepiece.
Yeah, the diagonal.
Yeah, I'm sorry, the diagonal.
Duly noted. I'll do that next time I'm looking at Jupiter.
All right, so if there's no other observing reports, let's take a snack break. It is 7:26. Wow, early. So let's reconvene 20 minutes. So 7:50.
That's fine. If anybody's interested, I put a link in the chat to my photographic Flickr account where all my astro imaging is.
Thank you.
Hey, Doug, I noticed on one of your recent Facebook posts where it had a picture of basically your observatory, the setup. I noticed you had 3 cooled cameras. Did you get a second 2600 MC?
No, I have 2 071s.
Oh, you have 2 older ones. Okay.
Yeah, I have the original cool camera, 071. And then I have the Pro 071, and then I have the 2600 Pro.
Okay. I didn't know you had 2 of the older ones. I knew you had 1 of the older ones. Okay.
And the original 071, which when they first came out, is now my guiding camera.
Yeah, that makes sense. I've been imaging the California Nebula and the jellyfish as one set up for the other. I think I have enough data to do the California Nebula. I have 3 nights on it. The jellyfish, I don't have enough hours to get a good photo, I don't think. So hopefully, if I get some time, I might be able to actually have an image ready for next meeting.
I actually have another guide camera that I bought initially back in January 2017. It was a Lodestar 2, but I don't use that anymore.
I have so many planetary cameras I buy and sell them. I have about 8 or 9, and I use them for guide cameras, and I probably should sell off some of these because I just have more than I can use. I know that's a weird statement.
I know. I've got problems like that too. I got 15 telescopes and I only use 3.
Yeah.
Or 4. I use 4 scopes right now.
I have a lot of planetary cameras. What I don't have is a lot of big cooled cameras because they're very expensive. I'd love to have another 2600. So.
I've actually been contemplating getting another one. I won't get any bigger chip though because my optical train is only M42s.
I kind of like to get an MC Duo, 2600 MC Duo. Yeah. For one of my setups, just to shrink it down and get rid of the guide camera to make it ultra portable.
I figured if I were to go to a full frame, I'd have to buy myself a 3-inch focuser and a 3-inch on-axis guiding port and all that kind of stuff, and I don't want to spend that kind of money.
Depends on what telescope you're setting up for. You might not have that much. You're for your RC.
Yeah, I got a 4-inch. I've got a 4-inch aperture coming out the back end of that RC.
But I mean, how far is it corrected to? It probably is.
Yeah, it is.
Okay. I don't know much about that design, but some people get telescopes and they really don't have.
Yeah, I understand.
They're not fully corrected for a full frame image, and lots of issues. And like, hey, why are my stars wonky? And
Well, let me put it this way: if I go to a full 3-inch aperture and it's not flat, I guess I'll just have to buy that 12-inch plane wave.
Hey, I saw one for sale. I saw one for sale the other day.
What's that?
I saw one for sale the other day. It was a 12.5 inch for 12.5 thousand.
Yes, I know.
$1,000 an inch.
I know.
It was used.
Is Riyadh still on?
His camera's not on, but
he
I
might
don't
be
know.
going to get food.
I'll get him later then. By the way, you guys missed the big NASA announcement today. Did you get it, Bob Tremblay?
What announcement?
What you got? I'll look it up.
The big news is that NASA announced they found bones on the moon yesterday.
Oh, they did.
Bones on the moon. The cow didn't make it.
Nice.
The cow didn't make it.
You know.
You ever seen the movie Apollo 18? That explains it all.
I found that astronomers have a terrible sense of humor.
Dad joke.
They're dad jokes. Yeah, they're dad jokes.
Was somebody looking for me?
Yeah.
Bob Berta wanted to tell you a horrible joke.
Oh, okay. I just heard it then.
You didn't miss much. Well, maybe you did. I don't know. It depends on your sense of humor.
I was going to say, Dale, the GSO 10-inch RC though is just $3,000. So that's the reason I got it instead of a more expensive unit.
Well, full frame camera costs you more than that.
I know. Yeah, I haven't budgeted for $50,000 or $100,000 worth of equipment. So we'll stick with what I got.
Bob Berta, I just put something in chat. You said Bones on the Moon. It reminded me of the cover of the book Inherit the Stars by James P. Hogan, who was a buddy, actually. The cover shows two astronauts finding a spacesuit with a skeleton in it on the moon. And it's human, but the spacesuit is very, very old. And then the whole book goes through the scientific method about how they figure out what it is. And actually, when my wife took a class in college, that book was assigned by the teacher as a really good representation of the application of the scientific method and how to do it. So, but I met James P. Hogan. We brought him up to Michigan Tech to give a talk during there was a fair. The Science Fiction Club brought him up to talk about. He was an engineer before he became a science fiction author, and all of his books are highly technical. And thereafter we brought him up, we saw him at conventions for years and years afterwards, and he always like, "Hi, Bob Connie." He always wanted to talk with us, so it was pretty cool.
Is anybody in the club or online here? Has anybody chosen to go to Texas for the eclipse?
I chose Arkansas.
Because I've been doing my final logistical planning. I mean, we got our flights and everything. We're going to San Antonio. I know maybe Adrian was, but I asked him. He's like undecided.
Dale?
Yeah.
There are some people going, but they're never in these meetings. Dave Harrington's got a small group heading to Texas. He's already got his reservations.
So the place that I'm going to is it's basically in Uvalde. Everybody knows about that from the shooting they had. But it's west of San Antonio, and apparently there's a campground there. I'm not camping. I'm just going for day use. But the lady said there's a group from the Kalamazoo area, maybe Kalamazoo Astronomical Society. I don't know.
Yeah, there's a whole group going.
So I'm going to the same place they're going. Do you know anybody in that group?
Yeah, Eric Schreier. Eric Schreier. He's on Facebook. You can check it out.
How do you contact the guy?
Pardon me?
How do you spell that name?
Just a second. SCHREUR.
Recognize that name. I don't know that I've met him.
Well, he lives over in Kalamazoo. He worked at the planetarium there for years. He's retired. He's on my Facebook friends. He has plans of going with some other group. I don't know if it's a Kalamazoo group or not. But there's people from I'm trying to think if anyone in the Lowbrows is going down there. Well, I think some is, but I've recently kind of isolated myself from groups this time because I took 12 of us down to Tennessee in 2017 because and mostly family and some friends. None of them had ever seen one, so that's why they came along. They actually have asked me, was I going anywhere? I said, well, I'm going to be kind of 3 days in advance. I'll decide because I've got an RV. I can go anywhere.
I trade you a guide camera for your RV.
No, that's okay.
How about 2? No. Yeah, one of these days.
I actually, in 2017, I actually rented a motorhome for that trip. And that worked out great because we were originally going to Nebraska. Then we ended up taking a left turn on Saturday and heading down to Tennessee.
I went out to Wyoming. So for this trip, everybody, I mean, I got my flights, but the hotels, the car rental, everything is just expensive.
I know.
You know, so try to rent a minivan. The minivans are triple the price of cars.
I know.
You know, so renting an RV is just you have to have 3 years advance notice.
Yeah, I mean, I scheduled a reservation for an RV about a year in advance, and the whole trip cost about $3,000 with about $1,000 worth of gas.
I thought about driving down. It's just time away from work, really.
The other thing I do is to make it
Yeah, we have about a dozen people from various states converging in on that spot. Finalizing the plans here. TikTok down. I'm actually going to take a 3rd scope down with me, so need to get all my logistics in order because that's actually becoming an issue.
If I do go, I don't plan on doing any imaging of it, just some viewing with my 6-inch Schmidt.
I'm going to do imaging as well as I'm going to have a solar scope there for viewing beforehand, mostly. Probably imaging during.
Remember what time we were going to resume? Said 7:55. Yeah. Not closer. Got just about 10 more minutes.
And my brother's really well, and as the close like okay. He's about, luckily have okay. Yeah. My dentist is right there. There's, I love how you're using it because like I told my friend,
Doug, so I found a guy on Facebook named Eric Schreier.
Yeah.
Schreier, U.S. Army veteran. He lives in Lowell, Michigan. Is that him? Lowell's closer to Grand Rapids than Kalamazoo.
Yeah, that's not him.
Okay.
That's interesting. Let me look at my list of friends. He's got his
Hold on. I see a guy in an astrophotography group. No, this must be the guy. He has a little observatory in his backyard, little dome.
got a dome.
Yeah, this must be him.
And he's got
mutual friend, Doug Bach. There we go. All right.
Yeah, that's him.
Okay.
Former planetary coordinator at Kalamazoo Valley Museum.
There we go.
I have to pull my laptop out whenever I'm in a Zoom meeting because it works on Zoom, or Zoom works on it. On my big computer, Zoom doesn't work.
Yes, sir. The ocean should have been a single story, 2 to 3 bedrooms. It's missing the kids in the living room. But when they go with like my mom was and I thought there was another bedroom on the main floor.
Bill Beers just got.
So they sold it, they turned on the schools, they sell the property, develop it. Now they got these expansion codes. And they increase the power. Duh.
It's on Harvard. First block, literally right behind the hospital. I got some job.
Starting again in March. March 9th. I'm doing one of these. It's supposed to be
What time is it?
Just at the library. The libraries are all, they went through a big box issue, so they're revamped all the libraries, so they actually have some nice.
Alexa, what time is it?
Set up with,
Alexa, what time is it?
Which, no one really had it. Last time.
It is 7:44.
That's probably where I draw presentation.
This is the male version of Alexa.
Oh, yeah. They really fix them up. The central branch is downtown, right off the Kirkland. So you just go past Cottage Hospital. And in the back of the building, you'll see House Point. That's central.
Is there a John Cleese version of Alexa?
The other one is the Ewald branch, which is over in.
I always want to change my navigation voice in my truck.
It's over by the.
They should have a portfolio of voice actors. They pick from it. They can change it every week.
I think they do. I mean, I know. I think there is a John Cleese voice. I mean, or was that Waze had one?
Well, maybe for Google Maps on your cell phone, but if you've got a built-in navigation system on your vehicle, they probably don't have anything.
Unless you can hack it.
No, that's all right. That's all I need to do is take my truck and say, it's not working because I messed with it.
All right, we got 5 minutes before we start. Everybody, get your bio break in and get your last drink and munchie, and 5 minutes. Oh, it sounds very busy there at Macomb, which is actually good. Makes me very happy.
We ready?
Are we?
I guess we are.
Okay, we can start now.
So our speaker tonight is Ron Kyle. Has lived in Dryden, Michigan since 2006. He got started being interested in space back during the Apollo days, like a lot of people did who were around then. He became interested in astronomy over a decade ago. Got involved with the Seven Ponds Astronomy Club. Enjoys doing astronomy with a telescope. He's also into amateur radio and plays the guitar. Well-rounded guy. Been married for a long time and 2 adult daughters. So I forgot to cue things up here, but let's figure out how to share this. What did I do wrong? Looking for share screen. Did I do the right thing here? Looks too small. Should have done this during the break. Sorry, I didn't. I'm getting all tangled up here.
Happy for you, Dale.
Thank you.
Once you get your...
Somebody know how to do this?
Yeah, I presume all the time for tutoring and teaching.
Okay.
Up there and see what you
Yeah.
figure out. I'm kind of a pro after 4 years of COVID learning.
So he's got a PowerPoint on the screen.
Okay.
Can
So,
you?
yeah, let's see what I can do.
We've got an expert here.
Maybe.
Sign her up.
Yeah, you got to come back.
Thanks.
Good thing she showed up.
Yes.
So you're trying to get to a PowerPoint?
Yes, it was on the screen. It's
Okay.
right there.
Okay. So if we go to share screen, Chrome tab, window, boom. There we go.
Wunderbar.
Yay for teachers.
Oh, now what did I do?
There you go. There you go. It's good.
Total ignorance.
All right. Good evening. Welcome. Yes, appreciate the warm welcome from Dale. And welcome to everyone who's here tonight. And to everyone who is here on Zoom. This is the first time that I've actually given this presentation where I'm somewhat tied behind a laptop, because when I give the presentation, I kind of like to go to the screen and point. So it'll be a little bit of a learning curve, but hey.
Oh, go ahead and angle the laptop. Go ahead, walk around.
Okay, we can do that.
Well,
as long as the audio's good.
Yeah, as long as they can hear you.
Yeah. Well, I'm an amateur radio operator. If they can't hear me, then I've got a problem with my microphone, right?
You're just fine. I can hear you fine.
Okay, perfect. Good. So thank you. Welcome. Tonight we're going to delve into what is called Astronomy 101, and I call this presentation Somewhat Light. Now, somewhat light is not referring to the number of slides as Dale just brought, but I will do my best, especially with the clock in the back, to try to get, 45 minutes, 50 minutes?
No.
Hour, okay. If I can't get it done in an hour, you're welcome to just cut off my microphone, okay? All right, so this is a presentation. I always like to start this with something that was brought to my attention a couple years ago, that what you're going to see tonight is not unique. There are other presentations out there. This presentation was actually, I believe, originally started by the Ford Astronomy Club a number of years ago. So there may be slides and elements of it that look familiar. There may be elements that are new. And much like if you're in the world of engineering, when you have design failure mode and effect analysis and other documents, we call them living documents. They're supposed to follow the product that you bring out to launch. This is as well. So I want to acknowledge those who have contributed in the past, and hopefully you will find it interesting. Okay, so before we start, since this is hopefully not going to be a passive learning environment, but what I call more of an active learning environment, let's engage our brains, okay? So I've got some riddles here, and either those online or those who are present here, see if you can provide the answers. It says, give me food and I will live, give me water and I will die, what am I? Fire. Okay, let's try another one. When you have me, you immediately feel like sharing me, but if you do share me, you do not have me. What is it? A secret. And one more. First, I threw away the outside and cooked the inside. Then I ate the outside and I threw away the inside. What did I just eat? Corn on the cob.
Corn on the cob.
Okay, well, it's a good thing we engaged our brains, right? Because most of us are thinking television. Well, it's not in clear skies, but let's continue going on. What is black when it's red when you use it, and white when you are all through with it? I gave you the answer ahead of time. That would be charcoal. Okay, enough of that silliness. Let's get into the good things. Okay, this is something that I attempted to do. Dale would appreciate this being a professor. This was part of what I call an academic exercise. And at the time, I went through, and I'm not going to read everything here on the screen, but it explores at least 4 different methods of learning and highlights some of the pros and cons of each of the methods of learning. And and I gave some examples here as well. And what I wanted to show you is that our preferred method of learning here tonight will be empirical. That is the 4th one that you see on the screen. So we'll do that because it's favored by scientists. It utilizes the scientific method. Things are repeatable. And it limits coerced investigations and conclusions. You're going to gather evidence, and that evidence will stand the test of time unless you get something what's called a paradigm shift, but that'll be outside the scope of our discussion for tonight. So again, I just highlight where we're going to go tonight. Now, before we really get going on Astronomy 101, this says, Houston, we have a problem. This is what's called the forgetting curve. You can see that what this really highlights is that on day 1, let's say what you see on the left-hand side, that is the information that you're going to receive today. On day one, you can see that the retention level drops down to about 45%. What actually happens when we get down to day 7? What you see, what you've heard is already going to start to diminish. So the question is, and it's similar to either string beads without a knot or trying to extract water from a pail that has holes in it.
Because you were never available that hour.
So what thing can we do? And this is where your part comes in. I mentioned a few minutes ago that we are going to go from a passive to hopefully a learning activity. I will hopefully try to draw as many as I can in who are present here tonight and those online so that we can all learn together and try to.
Something other than your asshole.
Okay, well, I'm not sure what that was, but we're going to try to beat the learning curve, if you will, right? So permanent learning does take time. And as you can see from the 2 slides up there, what we're going to try to focus on is building one brick at a time. And that's a wall that's built like that is going to stand the test of time versus one that is just kind of a hodgepodge putting together. That's our focus. So let's try to make this an active learning environment and avoid the one that has the red circle. So as Confucius said once, I hear and I forget, I see and I remember, I do, I apply, and then I understand. So draw yourself in and try to make this as passive of not passive, but an active learning environment as possible. These are the topics then that we're going to get into tonight. We're going to cover what the definition of astronomy is. We're going to briefly explore some of the tools that help us see the night sky. We're then going to go into how astronomers measure distance and between two objects, how astronomers organize the night sky, and then some common and not so common objects are in the sky itself. So let's get into topic number 1. Now, one thing that as astronomers, if you've ever been to a star party, we've probably had at least once where someone from the public will come up and what's one of the first things they'll say? Mr. Astronomer, Mrs. Astronomer, I love the study of astrology. What can you share with me? Has anyone ever had that experience? Yes. Okay, if you haven't, if you go to enough star parties, it'll happen. I once took a course, in fact, working in safety interior engineering. Our products are what we call Class 9 compliant. So in order for us to designate our airbag inflators and our pyrotechnic devices on seatbelts, which fall into Class 9, when I took a course in this many, many years ago, the first thing that we learned is that it begins by definition and it begins by technology. So let's get into what a definition of astronomy is and how that compares and contrasts with astrology. So I'm not going to read everything that's on the screen, but we'll take a look at the sub-bullet points. And we'll read the definition of astronomy. It is the scientific study. Doesn't that sound familiar with what we talked about a few slides ago? We were taking the empirical learning method of the universe and the objects in it, including planets, stars, nebula, and galaxies. We were just talking about galaxies here just a little bit ago on M81, which was documented by Charles Messier back in the 1750s, 1760s or so. Now, let's take a look at what I would call a common definition of astrology. It is the interpretation of the influences of the stars and planets on people's lives and behaviors. And then here's some sub-bullet points that are pertinent to astrology as well. So by definition, astronomy does not equal astrology. So, does anyone remember my first slide when I said that this presentation was called Astronomy 101 Light? Okay, if you did or if you didn't, what I have before here is an example of a college syllabus on Astronomy 101. And as you can tell by the different chapters, the tests, and the topics, this would be probably a 3 or 4 hour credit course, usually twice a week, maybe 3 times a week. It could be once a night if it's a 4-hour college course over a period of 16 weeks. This would be a full-blown Astronomy 101 course. So what we've actually got is, as you can see here, we're taking the information. See, I told you I couldn't stay behind the laptop long. Is you've got the full-blown version of Astronomy 101 and the topics that we're going to talk about tonight. So what is the difference, or what is the limiting factor in these two examples? Time and money. Whoop, and that one just jumped ahead pretty quickly. You must have a sensitive key. So I include this slide here because this is an address. You can look it up on Google, called 123 Main Street, somewhere, USA. What is the difference between the two skies? Light pollution. Now, true story. Everyone's got their journey in astronomy, right? When I first heard the word light pollution, and Dale, you probably may have heard me even say this before too. When I heard about light pollution, I thought it was either originally referring to the weight of the object, or if it was paper that flew out the window, that would be let's say you have a chunk of rock, or if you spill battery acid, that would be heavy pollution. If you have a piece of paper that gets blown out the window, that would be light pollution. Well, as I soon discovered in this astronomy journey, this is not the type of light we're talking about. We're talking about either the presence or absence of light and what it does to our view of the night sky. So again, light pollution, as the slide indicates. So let's move on then to topic 2, other useful tools to study and see the night sky. First thing is, and what do we have a picture of there? Anyone? Eye, yeah, very good. Okay, I want to make sure you hadn't drifted off because I know we've got some Coke and caffeine. I didn't see any coffee here, but hopefully everyone is still with me. So, the first thing that we do, we use eyes or an eye when you observe the night sky. You can tell that based upon whether you're dealing with a young eye or an older eye, that gives an equivalent of the an actual telescope. Oh, boy, this is sensitive. What if you wear glasses? If you wear glasses, every telescope has a focusing knob. You can either take your glasses off and view or keep your glasses on. It's completely up to you. Most astronomers, yes. It'd be approximately what the diameter of the telescope it would be.
That's the diameter.
Yeah, diameter. Yes, yes, the pupil itself. Correct. Okay, so we talked about eyes, and what's another part of our body that we can use for measuring the night sky? Hands. That's right. So you can see here that you can utilize, as you can see on the left, individual is measuring the angular size of the moon. He is also, and what you can see basically in the right-hand side is by stretching out your hand, you can use that as a close approximation for what your distance is in the night sky. Very, very useful. And what if someone's hand or someone's arm is longer versus shorter? It still is a close approximation. So let's move on. You can also not only use eyes and hands, but you can use them together. So you can see here that when we look straight up 90 degrees, we call that the, what do we see on the screen? Zenith. Does anyone remember an old television by the name of Zenith? I know I'm dating myself. Yep. Yep, exactly. Back in the day, right? When you had to keep it plugged in all the time, so otherwise you'd have to wait about 10 minutes for the tube to actually warm up and show something. So yeah, when you look straight up 90 degrees, it's you're looking at the zenith, and you can see the other directions here that are referenced. So usually if this is 90, if you go about halfway between 90s, so 90 divided by 2 is 45. So that kind of gives you a good approximation. Another device that's not necessarily part of the human body, but it could be an extension of it, would be binoculars. So this is this gives you a slide, goes to show you the two different types of binoculars that are available. There are pros and cons to both, but just to know that if someone's starting out in astronomy, before you go and invest in a telescope, I would always recommend, number one, go to a star party and try out other people's telescopes. And number two, if you do want to go beyond just what you can see on naked eye, get yourself a good pair of binoculars. Why binoculars? If astronomy ends up not being your shtick, you've got a great pair of binoculars that you can use for terrestrial viewing. And if you ever get back into it, it'll also serve you at night, and you're not out a lot of money. So these kind of give you some pros and cons and things that you can see. And this is just another slide that gives us some more information based upon the size of the binoculars. And then obviously we're getting into telescopes themselves. So you can see, whoops. So what are the telescope types? Primarily 3 types that we're talking about. A refracting telescope, where you can see where the light source comes directly in at the end, hits a mirror, usually at a 45-degree angle, and then you see that through the eyepiece. A refracting, where you can see where the image comes in, bounces off, and then goes through the eyepiece. And a pandioptic telescope, and you can see that there's, when you're reducing the overall size of the tube itself, you have to make a little difference and how that works. So there are pros and cons to each. Now this gentleman here is a weather forecaster. I believe he's out in Minnesota, and his name is Mike Lynch. So for well, I'd like to say he does actually go out and with these telescopes. What's that? Yeah, these are all his. So what I'd like to say is, for a guy that forecasts the weather and is probably accurate maybe 30-40% of the time, he does pretty well to be able to have a telescope family like that. But if you go out to his website, he definitely engages in the public and tries to look at the night sky. And I think the slogan that he uses, he says, let's make the old stars your new friends. So good guy. And yeah, this is just a small part of his family that he has there. And then there's some other individuals that you can see, different types of scopes. Sometimes you can take a pair of binoculars and have them fixed and be able to do some observing. This is an example of, I believe, astronomy at the beach. And again, we talked earlier about star parties. I think astronomy at the beach, I'm not sure what time it's going to be this year.
It's in the fall.
It's in the fall. Okay, thank you. So if you've never been, it's over, I think it used to be where Kensington State Park, or the county park. Yeah, yes, thank you, Island Lakes. So a good place to be able to check out other telescopes, be able to converse with other astronomers, and be able to learn some good information. Okay. Is anyone here young enough to remember something that's called a Kodak moment? Okay, good. This is one of these Kodak moments. someone's going to ask which telescope is best. So don't have to pull out your Kodaks, but most of us should probably have a cell phone. Feel free to snap a picture of that. That will give you some basic information about the pros and cons of the 3 different types of telescopes that we just briefly reviewed. So I'll let everyone either online or here in the room grab this information, and then we'll move on. Okay, does anyone know what this object is? Yes, correct. This is my favorite telescope. Of the ones that I have, this is one of the favorite ones that I own. Now you're saying, how in the world do I own this? Taxes, exactly. So we all own this. Unfortunately, we don't get full access to it, but yeah, this is the Hubble telescope. We also have this one that was recently launched. Well, recently is kind of a term, but this would be the James Webb Telescope, exactly. Whoa, this is there must be some static electricity in here. Okay, so let's keep going with topic 3. Now let's get into how astronomers measure distance to and between objects. We have what's called the Universal System of Units. So these are some standards. Velocity of light travels at 186,000 miles per second. And you can see that light takes roughly about 8 minutes to travel between us and the Earth, or from the sun and the Earth, and that's what we call 1 astronomical unit. And then you can also see the speed at which light travels in a year, which is approximately 6 trillion miles. Okay, so this is just, now we're this kind of goes into a little bit more detail about scientific notation itself with coefficients, bases, and exponents. We're not going to get too technical, but this might be another good slide where you can pull out your camera and take another Kodak moment, because as you go on with your astronomy journey, you're going to probably see things that are written in scientific notation. So it's good to have an understanding of that. So let's take a look at a practical example. Does anyone know what this is a photo of? Yeah. Do you know which football stadium? Yes. And I think, didn't they have some sort of a national championship that they just, in case we have some state fans here, I don't want to get booed out of here. Now,
Go blue!
Yeah, there you go. All right. So we got about 100,000 people in this photo. I think when this picture was taken, I was right up about there. You'll have to take my word for it because I don't have the resolution to zoom in. So if we said there's approximately 100,000 people in this photo, using what we just learned a slide ago, how would we describe that in scientific notation?
The math teacher knows.
Yes.
1 times 10 to the 5th.
Bingo.
Oh, it's up there too.
Yeah, it is. Good.
Retired math teacher, yeah.
No, yeah, excellent. Nice. Did you get into pre-calc or calc, or did you?
I did pre-calc. I've forgotten so much math that I learned in college. I forgot more math than most people ever learned probably in college. So I can do up to stats, but I can't do any classes.
Oh, very nice.
Yeah.
And I had a lot of higher end math too, but unless it's something that you're using every day, it's
like a learning curve graph.
yeah, exactly. That's right. Yes, exactly. Okay, so let's continue on. Let's look at the scales of the universe. So what this slide highlights are objects that are really large and objects that are really small. What we can also define, those that are large, we call the macrocosm, and those that are where you're measuring things that are very, very small, such as a proton, we'll call that the microcosm. So we took a look at, we're looking at scientific notation again, where you can see where there's different units of different objects. You can take the same objects using scientific notation and have a standardized way of describing those things. Now, we also earlier heard about light years, how fast light travels in a year, which is about 6 trillion miles. So we're going to zoom out here a couple light years, and I'll give you different examples of the galaxies, our sun's location. There's our Milky Way, as you can see, 500,000 light years. So our huge Milky Way is becoming pretty small. So hopefully the key takeaway that you're seeing on this thing is that when we talked about the size of objects and the night sky are huge, and the distance between objects are huge, this just kind of gives you an idea of some of those objects. And here's one of 1 billion light years away. Okay. Let's move on then to how astronomers organize the night sky to help them locate objects in it. So this is an example, as you can see, that ancient astronomers used imaginary pictures, and now it's modern astronomers actually take and divide the night sky into 88 official constellations. We're not going to review all 88. That would be outside the scope of an Astronomy 101 light, but just keep that number 88 in mind, if you will. And this will give you some example of some other objects. And in this slide, you should be able to, as astronomers, if you've not heard this phrase before, you'll see where you can arc to Arcturus, you can speed on the Spica, and that you can reach to Regulus. So this image here illustrates all three. Has anyone seen the winter triangle this winter? On one of the few clear nights that we have had, right? I heard Doug Box telling us earlier he's only had a chance to image, once in the last 3 months since November. Frustrating. We also have, you've got a winter triangle. You also have a summer triangle. So let's keep moving on. And we're going to study a little bit more about Earth. So we looked at galaxies. We've looked at things that are pretty far away from us. Let's go ahead and come a little bit closer to home and take a look at what's called the solar system. So what's in our solar system? Let's see if we can name the objects. The first object we have would be sun, and what comes next from closest to the sun going out would be, next. Good. Right. Excellent. And you got asteroids, moons, comets, and the Kuiper Belt. And Pluto? Yeah, exactly. And we'll get to Pluto here in just a minute. And that's why I put a question mark on there, right? And just as a little precursor, a little teaser, where we said it all begins by definition, we'll have a couple slides of that coming up in a minute. Okay, before we get into those, let's take a look at comparison of planets to themselves and other objects. So you have here, from left to right, this is Earth, Neptune, Mercury, Mars, Venus, and Earth. And there's order size. So the same size Earth here, down here, as you can see, our Earth is pretty large compared to Mercury, but yet it appears to be pretty small in comparison with Jupiter, right? Let's take a look. Remember how large we saw Jupiter being on this screen? Now comparing that with some of the other stars that are out there, it's a pretty small object. Now continuing to compare other stars out there, so you can tell that the size of objects are huge and the distance between them do tend to be very large. I talked a few minutes ago about Kodak moments. Our next couple slides, you're going to see a very what you're going to see is this type of a slide for each of the objects that reviewed in our solar system. So this might be good to get your Kodak moment. We're obviously not going to read everything here, but this would be good as reference information, whether you're new to the hobby or just as a reinforcement, because again, this is scientific method. New information is discovered or rediscovered or clarified. So this would be a good place to go. So let's see if I can get this part to work. This is usually a good place where, and I don't know how loud the volume will be, but hopefully we will have a video that pops up and you can hear a different voice for a moment or two other than mine.
If we could open up the sun, we'd see layers of dense hydrogen gas, hundreds of thousands of miles deep. And at its center, the core, the sun gives birth to light. Forged in one of the most violent reactions in the universe, nuclear fusion.
The specific nuclear reaction that powers the sun is fusion. Fusion of hydrogen into helium. You take two hydrogen atoms, you ram them together, and what's left over is a helium atom.
It sounds simple enough, but it's not.
It's actually hard to get two atoms to fuse. Two protons have the same charge, they're both positively charged, they want to repel each other.
Protons don't like to get close together. They have to come together with a huge amount of energy or velocity to get close enough to begin to fuse. And that's very, very rare.
To force protons together, it takes immense amounts of heat and pressure, generated by the invisible hand of gravity. The sun contains 99.8% of all the matter in the solar system. That's a lot of mass. All that mass pulls the sun together with unimaginable gravitational force.
With gravity crushing things down, things get close enough together, and nuclear fusion happens.
In this nuclear compactor, hydrogen atoms slam together 100 million quadrillion times each second. Some of these collisions are so powerful that atoms fuse, releasing energy.
When the protons come together, they bind together, they lose a little bit of mass, and that mass gets converted into energy. And every second of every day, about 5 million tons of stuff is being converted to energy. It's amazing.
Okay. So hopefully you enjoyed that video.
Hey, Ron,
Yeah.
the narrator is Mike Grove.
Mike Grove from Dirty Jobs.
Yeah.
Oh, really?
And if you ever saw him do this here,
Yes.
at the end of the show,
Yes.
it's like he invented that. It's not microwave.
I did not know that. I always, yeah, thank you.
Microwave.
Okay. Yeah, I love it. I love it. Thank you. Good. See, I learned something new every day, right? Remember back when we finished high school, when we had the baccalaureate, we also had an exercise we called commencement, right? Does anyone young enough remember a high school commencement? Does anyone know what the word commencement means in French? Beginnings. It's saying that now that you've got a base of understanding in high school, this is where your journey really begins to learn all there is to learn here on your journey of life. So, yep. And today is no exception. So thank you. Okay, let's move on and look at the terrestrial planets. They have two characteristics. They're closest to the sun, and they're generally made of rock and metal. So again, pull out your cameras. Those online are welcome to do the same thing. Okay, good. And let's look at Venus. And again, since this is Astronomy 101 Light, if we got into all the details here, we'd be moving well beyond an Astronomy 101 course. But this is an Astronomy 101 Light course that gives you some 201 and maybe even some 202 elements to give you some thoughts. And our near dear planet Earth, right? and I even threw one in there for the Earth's moon itself. And we also have Mars. Did anyone miss one of the slides? I can go back and grab it. No? Okay, perfect, good. Okay, so we talked about those that are closest to the sun. Now let's look at the planets that tend to be a little bit farther away. Those are what we call the gas giant planets. They are obviously the biggest planets. We saw that a couple slides ago in terms of their size, right? They typically have lots of moons. And the last time I gave this was at the Celestial Skies over Seven Ponds. And I showed a slide, and there was a young lady in the crowd. I mean, young lady, she was probably, I think she was in first grade or second grade. And she updated me and said, "No, Mr. Astronomer, sir." I thought it was really cute what she said. "The actual number of moons is this." And she just went on, and I thought, holy smokes, that's a future astronomical physicist or some NASA employee in the making. Again, let's look at all these slides. Jupiter and Saturn. And what comes next? Okay, let's look at one of Saturn's moons. This sitting up. We'll have a slide coming up here in a couple minutes that talks about the number of moons that are actually on Saturn. And I learned something interesting about this. I'll highlight that in just a minute. So this is one of Saturn's moons called Minos. And whatever hit Minos nearly destroyed it. And it remains, and you can see the impact in the craters are one of its smallest moons. And it kind of gives you some details about who highlighted it. And then it's made mostly of water ice with a smattering of rocks, so it's accurately described as a big, dirty snowball. So does Minos look very familiar? Bingo! I like the phrase that says, "There's nothing new under the sun." And this is an example of that, right? Yeah, yes, exactly. Yeah, exactly. The beginning of episode 4 versus the end, right? It didn't look the same at the end of 4. So let's look at the ice giant planets, and again, some key characteristics of them. Medium size, lots of moons, made mainly of gas, hydrogen, and helium. There's also some methane, water, and ammonia mixed as well. So again, that Kodak moment. Perfect. And we've got Neptune as well. And what about Pluto? We mentioned Pluto earlier. Now, one thing I found that was interesting is, has anyone looked at this month's, I'm not sure what the newsletter for Warren Astronomical Society? The front cover mentioned a gentleman whose name is Clyde Tombaugh, right? How is he related to this slide here? Bingo. He passed from this life on my birthday, January 17th, back in 1997. So, see, I learned 2 new things tonight. So I thought I would put that in there. So here we'll talk about Pluto, and maybe what's better asked is, what is a planet? So we can use that by reference when you look at what a continent is, and it gives an example. Why is Australia a continent, but yet Greenland is just an island? So again, you're looking at definitions. So it's the word that we're used to using. We haven't thought a whole lot about really what that means. And again, we're looking at empirical. That's our method of learning, empirical scientific method. As we gather more information, we have to take that information that's been verified and take a look at our definitions. As you get more information, does the definition of the old fit the new empirical model that we have today? So let's take a look at Earth. We know it's a planet, right? I think we'd all agree with that. Tends to be big, round, orbits the sun, has at least a moon, and it's made of rock and metal, and has atmosphere and life. Otherwise, if we didn't, we wouldn't be here having this time together, right? Okay, let's take a look at that. This just kind of gives some information about the word planet. Comes from the Greek word for wanderer. And back in 2006, they started taking a look at new empirical data and challenging or looking at the old definition. So in order for an object to be defined as a planet, it has to orbit the sun. Does Pluto meet that check? Yes. Does it have sufficient mass to be round or nearly round? Yes. Is it not a satellite moon of another object? Check. So far, so good, right? Has removed or cleared debris and small objects from the area around its orbit? Nope. So, Kodak moment again. So Pluto is now, by definition, based upon new empirical data, defined as a dwarf planet. But for some of us, I don't want to say old time, we'll say long time astronomers who've had an interest in the hobby, Pluto will always remain in our memory and in our heart, right? Yeah. Okay, this was that slide I told you about a couple minutes ago. I went out and updated this. I did not know that Jupiter had up to 95 moons. And I also learned something new tonight too, is that Saturn, I did not know that Saturn had more moons than Jupiter. For whatever reason, my mind was thinking otherwise. And then you can see where Uranus is up to 27 moons, Neptune has 14, and Pluto has 5 to 5 moons. That is as of early 2024. If time continues, I'll probably have to go and take a look at the same number here later this year or maybe into 2025. So this is current as of tonight. And this kind of gives you an example of different asteroids, their different sizes. So let's get in. I want to explore this topic a little bit. We talked about objects, sizes of them, but we're talking about large objects. So let's get into something that's called the Burnham models. Anyone ever heard of the Burnham model? It's brief background. It was started by it was actually compiled by a guy by the name of Robert Burnham, who was an astronomer at Lowell Observatory from 1959 to 1979. He published a 3-volume book called Celestial Handbook. Does anyone own a copy of that? You do? 3 of them. Yeah, the 3-volume. You've got all 3? Yes. So he put together a very, very provocative model. And here's the model. He discovered when he was compiling one of his volumes that it just happens to be, we could say that the number of inches in a statuette mile is about 63,360. The number of astronomical units in 1 light year is 63,294. So with both values being very, very close, not exact, but close enough to each other, that we can allow in this, what we call the Burnham model, 1 inch to represent the distance from the sun to the earth. Again, we're talking 93 million miles. Has anyone ever traveled more than 1 million miles in their lifetime? Probably not. If you have, then you've been in the backside of an airplane much too long in your life, right? So let's try to take a model that's huge in our solar system and compress it so that we can somewhat use something that we can kind of see, observe, and comprehend about sizes that make sense, that we can fit into our brain. So we're going to let 1 inch represent the distance from the sun to the earth. We're going to let 1 mile represent 1 light year. Is everyone with me so far? Okay, so 1 inch represents what? Perfect. And 1 mile represents what? Excellent, good. So let's take a look at this. So if we apply that same model, we will know the sun will be basically 1/100th of an inch in diameter. That is nearly, and I don't have one here. Isn't that funny? We're so much in the digital age. Just pretend like I had a pencil that I'm showing you the end of a pencil. That would be the size of our sun in this model, right? And if we break, and if we use that same model, this is going to give us a breakdown of the other values that are out there. Yes. Okay. If someone could someone please mute your microphone? I'm being asked to state that. And thank you. Okay. So let's apply the same model that we just looked at to the nearest star to us, which is Proxima Centauri. Proxima means, it's a Latin phrase meaning that which is closest to Centauri. So it's about the same size as our sun, and it's roughly about 4.5 light years away. That's basically, you're looking at 2 specks. Remember the ends of our pencil? They're roughly about 4.5 miles away in our model, right? What influence in this case, and this is just a question, I'm not going to actually give the answer, but I want to give you something to ponder on your way home. Don't think too much about it, but this will be something to ponder. What influence would gravity have between 2 objects, remembering Newton's law of gravity, which is basically the product of masses divided by the square of the distances between them? And in case you forgot, this is the actual formula itself, and you can see that it takes the distance and squares it. So think of that formula and the effect of gravity of 2 specks that are about 4.5 miles away from each other using our model, right? So this kind of gives you, well, it looks like this is a duplicate somehow that got carried over. So I guess I wanted to get the point over there twice, right? Okay, let's get into our last topic here, is common and not so common objects in the sky. This might be another good one for Kodak moment. It gives you examples of planets, stars, galaxies, nebulas. This is by no means completely comprehensive, but it'll give you examples of what there are things that you can see and learn about our night sky. We also have, if the skies were clear, this is a good object. In fact, I think before we began the discussion here, we were talking about the night sky of seeing Orion is a really good one. And that kind of gives you an example where that is. Talked about Orion Nebula. Has anyone ever seen Orion Nebula? Beautiful object, right? Okay, double star alberio. And whenever we have a star party and someone pulls this up, I always hear someone humming the song Hail to the Victors. I'm not sure why, but anyways, they do that nonetheless. M45, also known as Pleiades. Has anyone had a chance to be able to see Pleiades? This is a good naked eye object. Yes, thank you. This also happens to be my daughter's favorite object. She does not care to look at it with a pair of binoculars. She said, I've got young eyes, Dad. I can see it just fine the way it is. Thank you. Okay, we've got Hercules Globular Star Cluster M13. And then we've also got the Ring Nebula. And that's typically how you would see it through a telescope. There's auroras. Now, this is an interesting image. Don't remember the exact details, but this was a case where the Hubble telescope that we saw number of slides back, that they decided to take the Hubble and aim over to an area of the sky that was completely black. And what they said, okay, we're just going to go study that area. Uh-oh. I forgot. Well, my battery is probably going to die, so I forgot to plug this one in, so we'll see how we do, right? Maybe if I go like that, I can save the battery a little bit. Okay, so this is like looking through an 8-foot long soda straw, and after they image this, of course,
Just a second, we're getting some power.
yeah, and I do have a power supply.
I need some light to see what I'm doing.
Well, let's just use this one back here.
You know how wide this field is?
Okay, there we go. Okay. Okay, well.
It's about a tenth of it.
Yeah. Okay. It's acting slow. Okay. Well, what you saw on the slide prior to this, which I just can't seem to get back to, maybe because of the response time of this laptop, is that the objects that you saw on there, over 10,000 of those, imagine looking through a straw, 8 feet long, looking at a image area of the sky that's never been observed. They discovered over 10,000 new galaxies. There's a lot that we know, and there's a whole lot more that we don't know, right? Okay. For whatever reason, this is very, very slow. Okay. So maybe I'll just have to do it this way. So let's do a quick review of tonight's topics. Is astronomy and astrology the same thing? Yes or no? Okay, good. Did we learn that there's at least a few tools that are available to learn and enjoy the night sky? What are some of those tools? Anyone? Perfect. Excellent. Good. Okay. Did we learn that the universe and the distance between objects tend to be very large, and that scientific notation definitely helps to standardize the way in which we can measure objects? And yes? Okay. And astronomers often use the position of constellations and certain stars to explore more rare deep sky objects, what we call DSOs. Not to be confused with the DSO Detroit Symphony Orchestra, right? Okay. I knew someone out there was thinking that. Okay. You might be now asking yourself, so how do I find these things, right? What resources are available to help me learn more? Has anyone thought that here tonight? Okay, good. Well, I passed out one of these. So this is a current copy. What I like about this is this front page that you can see on the screen and that I'm holding up with my hand too, gives you what is available, what's in the night sky here in February 2024. The back page lets you know the objects that you can see. Now check this out. It includes what you can see with your naked eye, what you can see if you do the same observing with a binocular, and if you have a telescope. So even if you don't have a telescope and you might be able to borrow someone's pair of binoculars, I would recommend you try to fix them. Otherwise, you're going to see dancing objects. There's a lot that you can see. We just have to get a big wind machine and blow the clouds out of the way. But hopefully that'll happen with us soon, right? Okay. This might be a good slide again for a Kodak moment. This gives you a list of, not comprehensive, but a good place to gather other information related to astronomy. And also, don't forget about your local library. And I think this is one of my last slides. This is a common greeting if you've not been around astronomers, especially those in Michigan. We wish each other clear skies because we don't often get them, but when we get them, we enjoy the night sky, right? I can try to go back. Yeah, I think it was. Let's see if this will. No, it's not. I'd have to probably jump out to go back. Okay, so these are some of the reference materials. Like I stated in the beginning, this presentation was started by the Ford Club, and then other resources along the way were used to make the presentation in its current form. So just like a good research paper where you want to reference your resources, I use that here as well. And that concludes my presentation for tonight. Thank you. Yeah.
For the moment, okay.
Yeah, we could do that.
Anybody have a question?
No questions?
Okay, thank you.
For those on Zoom, I posted a whole bunch of links while he was talking about things he was talking about, so can explore those. So are we done with the questions?
Yeah.
Alrighty. Well, let's give a hand. Thank our speaker again, and yay! Thank you. So. Our next star party will be Saturday, February 24th at dark 30. Our next board meeting will be via Zoom Monday the 26th, so just board members be aware of that. For the folks there at Macomb, we generally meet afterwards at the National Coney Island on Groesbeck, just south of 12 Mile. So if you're at Macomb, go ahead. Officers, remember to get your reports to Dale for the next newsletter, and that's it. Clear skies, everyone. Thanks for coming.
Okay.
Alrighty.
There are at least 3 of us that are going to the National Coney Island right after this meeting.
Where is he?
You go to Van Dyke from here.
Oh, you're going to Van Dyke?
There's
one at Groesbeck south of 12, and there's one at Van Dyke north of 12.
Look it up and get for the